Checking once. Hey, what's up, everybody? This is page 412. We're continuing activity 3. A reminder, activity 3 has been about properties of trapezoids. Let me go ahead and show the screen here. Properties of trapezoids with one pair of parallel sides. And so you've been working through this one. We've got a few more things to talk about on the condition of properties of trapezoids. And so I want to bring that to our work right here, right now. Have a highlighter. And let's get into it. Prove that the diagonals of an isosceles trapezoid are congruent. That was one of the properties that was next to the trapezoids on page 420. Now, if you look at the diagonals of the trapezoids that we have here, that would be like showing RP as a diagonal is exactly the same as TA. That's our proved statement. We're going to get there through a couple of things. We're going to get through the fact that we have a trapezoid. So in a trapezoid, add some notation here. The base, like sides, are not congruent. They're parallel, right? RA is parallel to TP. We see that in the given statement right here. Bring in a little more color. We also have that TR and PA are congruent because if it's an isosceles trapezoid, one of the facts about isosceles trapezoids are that the sides, non-parallel sides, those sides are actually going to be congruent too. But they're like aiming towards each other, right? So therefore, they don't make a parallelogram, they make an isosceles trapezoid. Well, we're going to prove that TA and PR are actually the diagonals. They're actually congruent, and honestly, it's going to happen through a triangle congruence theorem. Most of the times we want to show that angles or sides are congruent. That's how we get there. Let's start off with the givens. And so I'm going to go ahead and reveal just one line at a time the information from this one. And let's give me as much space as possible. Okay, so first of all, it's right there. It's a given. Isosceles trapezoid, TRAP. It has a pair of parallel sides, so TP is parallel to RA, and because of isosceles, TR and PA are congruent. So I'm just trying to really rewrite what's up here in the givens. Now, if we have this situation where it's an isosceles trapezoid and we have the parallel sides, well, that means we can actually say the base angles are congruent. So specifically focusing on RTP, so that angle right there, and angle APT, this angle over here, they are base angles of an isosceles trapezoid. So we know from the other pages that we've worked on that base angles of isosceles trapezoids are actually congruent also. We're setting up a triangle congruence. We've got a pair of sides that are congruent. We've got a pair of angles. It might be good for us to actually identify the triangle we're talking about. Let's talk about triangle RTP, because RP is on that triangle. And let's compare it with triangle APT. Those two triangles are actually the triangles that we're going to show that are congruent. And if those two triangles are congruent, then lines that correspond on those triangles will also be congruent. We're almost there. We're 2/3 of the way forward with our proof. And the last one, duh, TP is the same line on both triangles. It was highlighted both orange and green. And so because TP is the same line for both triangles, reflexive property, that therefore means that the triangles are actually congruent. The triangle RTP is congruent to triangle ATP, or switch the letters around, PT. And it's side angle side. We have a pair of sides, a pair of angles, and a pair of sides. So SAS, triangle congruence theorem. And if the triangles are congruent, then those diagonals that are on the triangle, they must also be congruent. Let's draw that in. I wanted to leave this one as a part that I write in with you right now. The prove is what we put on the very last line. So TA is congruent, that's a segment, to PR. And the reason for that, if you have reason number 4 is triangle congruence, then reason number 5 must follow that. And the only one that can follow is corresponding parts of congruent triangles are congruent. These are corresponding parts. They're parts of congruent triangles. So if the triangles are congruent, those parts must be congruent. And there you have it. That is how we can prove from this point on that a statement that was made, that we put together on page 420, The diagonals of an isosceles trapezoid are actually congruent. Here's our proof of it. We have another one we're going to talk about. Let's go ahead and move forward. Video, moving forward. Let's go get a focus in there. You also conjectured that the length of the midsegment connecting the legs of a trapezoid is half the sum of its base lengths, and the midsegment is parallel to each base. Well, to prove this conjecture regarding the midsegment of a trapezoid, it is necessary to connect points M and E, so connect M and E, to form a line segment, and then extend that line segment until it intersects some like extension of the bottom edge. Like these sides, these lines create congruent because they're corresponding angles, and if they're corresponding angles, then maybe these alternate interior angles, they're also congruent. The whole point is that we're creating this parallel. JE is parallel to GM. That's what we would like to prove, right? If the triangles that are created create parallel like sides, we just want to make sure that we know that that midsegment is actually parallel to both bases, not just one, but both of them. And it turns out it is actually possible through the use of alternate interior angles. So there you have it. We need to write one more thing. The distance, how long JE is actually half of the combined length of DS plus GM. So whatever those two numbers are, those two lengths are, you can measure them, add them together, and divide by 2. And you wind up with the length of the midsegment. Or work in reverse. Maybe we know the length of the midsegment, but we don't know the length of one of the bases. We could reverse and solve to figure that information out. This has been page 412. Thank you for watching this video. There is more to follow. We are still continuing to push on what we understand, what we are learning. So stick around for some more, and I will see you in the next video.